In the spotlight, wow. It's right up here. Good morning, everyone. Thanks for coming out. Really appreciate the opportunity to share this with you today as far as what we've done and the approach that we're taking with our SCADA system. And we've had some good partners, and we kind of had the perfect window, to look at what we were doing with our SCADA system, because we had a lot of stuff that was end of life and was ready to be, renewed anyway. And so to take this cyber-informed, engineering approach, it just made sense. So what is, so it's consequence-driven cyber-informed engineering. That's the CCE. And this is something that Idaho National Lab actually won R&D 100 award for this year. And I think they're actually accepting today in San Mateo. But using these concepts as far as consequence prioritization, look in your system and look at what risks you have and the parts of your system that are sort of the crown jewels. What do you have that would be the biggest consequence if it failed, right? And taking extra precautions to protect that and mitigate the risk on those systems that cannot fail. And then system-by-system breakdown, identification of the multifaceted interdependencies between critical processes, your defensive systems that you have for protection, and enabling the components that you need to have work together. But a lot of things that when we started down this road that we would look at as far as the interdependencies, right? Because like a lot of agencies, there's areas where we kind of cross over and blend with our central IT and other departments. So just like for an example, our central IT handles all the HVAC throughout the buildings in the city. And you don't really think about that being that big of a situation on your process control system until you have servers in rooms that they control the HVAC. And if that system is hacked and drives up the temperature in those rooms to where you fail servers and lose, your process control system, then it's really going to affect, your business. So we looked at those relationships and where we needed to, partner and, kind of draw the lines of responsibility, consequence-based targeting, determining what the adversary must accomplish to achieve the highest impact effects, and where they needed to conduct the attack from, and the information required to achieve their goals. So another thing that we're really cognizant of is the amount of information that we have and what we share and what we have to protect. That we don't want IP addresses being out there as far as part of some public records request. That there's sensitive information that we have to protect, about our process control system, since it is critical infrastructure that we're working with. Mitigations and protections, production of a plan to remove and disrupt digital attack vectors as fully as possible. So we try, to where we're on our own fiber. We have our own firewalls. There's DMZs that we have to where if there's something where there's remote access, the city hosts the website and they have their firewall. And then on the other side of the DMZ, we have our SCADA firewall. So those kind of relationships working with our central IT people downtown have been really crucial. Developing that, that the first time that we're talking to this person isn't when there's a problem or isn't when somebody's requesting information. Those relationships have already been established. We know who to go to. We share information. If we get an alert on something, we see a phishing attack, we're sharing that information with them just like they are with us. Another thing as far as our critical processes, we don't run any email systems on our SCADA system. We do strictly the business of taking care of the process control. That's what it's there for. And we have another account, another computer that's on the city IT side for people to do that type of business on the enterprise side. So our agenda, I'll go through the Project background, why we chose the CCE, CIE, our process that we work through, lessons learned, and then where we go from here. So as an introduction, we have over 200 facilities throughout the city. We take care of water, wastewater, and the flood and drainage lift stations as well. So it's a pretty big system. And we recently went through, because we were running this master app to where every time every workstation booted up, it had to go out and touch, all of this information. And so we've split our app down between the water and the wastewater as much as possible. We have regional network sites out there that are running wells as well as lift stations. So it wasn't possible to just draw the line between water and wastewater. But as much as we could, we've isolated those areas, those process areas, to where that if something happens at a lift station, it's not going to affect our water plant. Before, we were running a flat network, like I said, where everything touched everything. And now we've got segmentation in place and firewalling in place to where we can isolate specific areas of the process. We have all the necessary hardware and software where that if that is isolated from the network, it can still continue to run locally. So 60% or 67%, somewhere in there, I don't know how we actually got that specific number, but of the hardware was at the end of commercialization. So these improvements aligned with our department's strategic plan, and then we developed a program to kind of quantify this. Before we had this plan, it was really difficult for our upper management and executive team. We would tell them, here we have these needs, and we're laying out, piece by piece. But once we partnered with a local firm to come up with a master plan that helped us to quantify and do some kind of class 5 level estimates. But once everybody's seen this dollar amount, then it got serious, right? And it got as far as us being able to get funding. Then it also, they knew there was a plan, right? There isn't like we're just asking for the money and maybe we're going to get to spend it and maybe we won't. We have a plan in place. We're working with a project management team, and here's what we need. So this involves replacing the majority of our SCADA hardware, upgrades to the communication network with the cybersecurity aspect in mind. And then the program management part, we're actually partnered with Wes Yost. They have a cybersecurity team that they have developed within probably, I'd say, the last 5 years, and that they're continuing to grow. But these are people that are familiar with process control, and they're familiar with cybersecurity and the threats, that when you're a critical infrastructure with an industrial control system, you're a target out there, not just to, somebody in the area now, but as we all know, there's state actors and other people that are targeting our critical infrastructure. So the reason that we chose to go with this method of CCE, so we had done some work with Idaho National Laboratories, who actually partners with the Department of Homeland Security, and we'd done a couple of assessments from the Department of Homeland Security, actually coming out, looking at our system. And so that was very revealing as far as where our needs were, where our gaps were, what we needed to address. And then we had our staff attend the Idaho National Lab training that's up in Idaho Falls. So that's through ICS CERT with the Department of Homeland Security. And it's like a 5-day class. That's free. You just have to pay for the room and travel for, for your staff to go, but there is no tuition. And it's, an awareness of, what your adversaries are using. So that was very informative. We come back from that. We got guys start, using Wireshark and some of the tools on our network, and what are all these IP addresses that are talking on our network? So that's another thing we roll into our spec as far as what parameters that we actually want enabled on our equipment, because we had a lot of devices that out of the box, they're programmed from the manufacturer to phone home, right, to try to sell you service and maintenance. But we don't need that traffic on our network unless we want it there. So in the West Yost, we've partnered with them. They're also working with Idaho National Labs on this concept that they're trying to now roll this out. It's been in the energy sector for a while, but now they're reaching out into the water sector and trying to support the water as well as energy. So we had also an opportunity by using these concepts to run, the AWWA cybersecurity assessment tool, which that's a brand new tool. They just rolled out, I believe, in October of this year for Cybersecurity Month, along with the AWEA, which is an assessment. So that's a mandate from the EPA that all water agencies, have to. Everybody's aware of the AWEA, so we took the control points, then the recommendations from the AWWA tool, and we're looking at that as we go through this program in our project. So then, reduction of risks and consequences from potential breaches, that was always a concern. Changing the way that our systems are engineered to take a baked-in versus bolt-on, approach. So I have an electrical background, right? And there's very few engineers, when I get a design on a project, that have taken in the consideration of 70E. Our arc flash and arc blast, which is a huge, safety factor on working conditions for electrical workers, right? And so, and I'm not sure everyone's familiar with that, but to try to mitigate those hazards after something's already been designed is sometimes impossible, right? You'll have stuff that's at lethal levels on the available fault current, and so there's just not PPE out there that's adequate to protect your staff. The only way they're going to work on it is shut it down. So whenever I heard about these concepts of taking the cybersecurity approach being part of the design and not trying to fix the problem after it's already built, I really was able to identify with that on what we were dealing with on the electrical side. These are just some of the partners. I mean, there's a lot of great resources out there. Just kind of threw up, some of the logos here. I got the links on one of the other slides at the end, but Water ISAC, we get alerts from Water ISAC. We get their quarterly, webinar briefing to hear what new things are happening, what alerts are going on. ICS CERT is now kind of morphed into the CISA for Cyber Infrastructure Security Agency, but they're constantly sending out alerts as to, when they find a vulnerability in a piece of equipment, then they're going to share that information with all of the people that are in the arena. They're in Idaho National Labs. They're really big as far as doing a lot of the research on these concepts. InfraGard, if you're not an InfraGard member and you're involved with critical infrastructure, I would encourage you to reach out to your local InfraGard chapter here in Sacramento. That's how that I became aware of a lot of these resources that were available, was through a quarterly InfraGard meeting. And then NIST, we try to follow the framework for the NIST 882. SANS is another great resource. Their training is pretty pricey, but they have a lot of resources that are available just on their website. Templates for policies and lessons learned, and they're great about sharing that information off their website. So our process, we had a workshop that involved our project team, and so we actually had a presentation from INL, Andy Bachman, who's wrote a lot of papers on this CCE concept from Idaho Labs, and so he was gracious enough to take the time to make a presentation for us, and so we could see the benefits and how that it would fit into our plan. And so then we had to review our standard specifications throughout the electrical, instrumentation, controls, updating those standards to where we have common language now, between our divisions, the water, wastewater, we're all, looking for the same type of components, same specifications. Then the CCE design guidelines for engineering consultants. So we want to make that clear of what our expectations are if we're partnering with a consultant that's going to be doing some design work for us. And reviewing our SCADA programming standards, making it clear as far as what we intend the software to be used for. What are function blocks for a pump, right? What logic that we want in there? Having a standard for that it isn't just job by job, depending on the contractor you get, that's the logic you get. We want to have standardization, which, across the board makes it, a lot easier to maintain, to train our people on, to troubleshoot and so forth. And then the PLC function blocks, same thing there, right? That we're looking at that logic, that we don't just, have some contractor that's coming in with all these extra data points just because the equipment is capable, right? How much data can you actually use? And there has to be a value, right, that somebody can validate to us of why they need the data. That we're not just collecting data, that's taking up storage, taking up network traffic, and it's all of that is more traffic to watch, right, on what's going on in our network. Looking at behavioral patterns of what's happening, of how these devices are talking and what traffic is going on. That's all things that we want to be able to narrow down and identify if there's some type of anomaly sooner than later. Then we reviewed our network architecture as well. Like I said, trying to follow the NIST 800 framework. A lot of segmentation went into this, and not just segmentation from different locations, but within a plant, what devices need to be on which VLAN, talking to, other devices. And so there's a lot of effort that went into that as far as making sure that the things that need to talk can, and we're not handcuffing our staff, but yet we're adding the extra protection. So lessons learned. The current engineering culture does not consider cybersecurity in traditional design. Right, that's like I said with the electrical. It's just things are changing so fast, and people have projects that they want to apply to your project of what they use there, and so it's something that like the next line, the standard specs may not completely cover your CIE. You need to evaluate on a case by case. What you need to apply in certain circumstances is kind of how we've looked at it. Like I said, we couldn't just separate all of our water nice and clean whenever we have, we share network between wells and lift stations and so forth. So it really is beneficial to have, the partners there and have your staff involved where you have input on what the needs are of the particular project. And then again, the design guidelines require, successful, that has to be there from the design all the way through. And not saying that you're going to catch everything. There's going to be things that are going to come up through the project, as with every project, but to try to catch as much of it on the front end as possible. So the technical details and additional disciplines to be considered, right? So like I mentioned, the electrical, mechanical, process, network, operations, we all have to work together as a team for the benefit of this. That our electrical people understand that, when our VFDs are on the network, our protective relays are on the network, that we apply this same process and this same methodology to that equipment as well. That we don't enable every parameter on a VFD just because it's there, right? And I think that's very crucial. That happens a lot. You'll see, and it's like we got all of this information that nobody does anything with. And so it's really important to validate that. Our vibration monitoring equipment for the mechanical guys, and what we've looked at on our process control is, does everything need to be, TCP/IP that's Ethernet enabled just because the device has it? We want to have that when we buy that capability when we buy the equipment, so that we can go out there, connect a laptop to it, troubleshoot it, do what we need to do, firmware updates and such. But do we really need that flow meter, right, riding on our Ethernet network? If we have an analog signal that's back to a PLC, right, is that appropriate in that situation? And that's where I was saying it's, you have to look at it as far as what fits your system, what fits your business plan. And if you don't need, to take the risk and enable something that's going to cause you a vulnerability, then don't. But just make an informed decision on that, right? That you can present that to your partners. And like I was saying, when you're having these discussions, that those relationships are already in place with your operations staff, with your other maintenance staff, that they understand where you're coming from. right? That you're not just trying to make your job easier, but there really is a vulnerability that you're trying to address. And I've already mentioned, our network segmentation, but we're employing the zero trust methods, right? So, like I said, we're not doing these any rules on our firewalls. We're looking at what actually needs to be talking, and whitelisting those and creating the policies in the firewalls accordingly. And then also with our operations staff, and this is the big one, right? And this is big, and as far as the design also, as far as that they're not solely reliant on the automation. If you had a major, event that happened, and you had a breach, can your process still operate manually? How many people would that take? We're working on developing what we call a day without SCADA, right? So we're going to get the teams together, first probably do some tabletops to get the buy-in, to see here's the plan and here's how we want to approach this, and then do some areas of the process where the SCADA system is down and we see if it can be operated manually. And I'm talking about back to the crown jewels, right? I mean, the things that are they cannot fail in your processes, that is going to affect, the life, health, and safety of your community if it's not there. So those are the things that, we're trying to qualify, okay, what fits in that category, and how do we want to, train our staff that if the screen goes dark, that they're just not going to, throw up their hands and be helpless. And then here are the links, as I mentioned, to these other resources, so the NIST and, US CERT, SANS, all of these people that are, just phenomenal as far as the resources that are available. And reaching out, just with the Homeland Security, like I said, I think we've had 3 different assessments, where their teams, no charge, have came out and reviewed with our team, where we're at, and gave us an assessment. And there's also online tools where you can do the same thing. The ICS CERT is pretty much along the lines of the AWWA cybersecurity assessment tool. And then these are just some recommended readings. These are our white papers that have been written on this concept of cyber-informed engineering. So one from SANS, and then we have another one that's actually from Idaho National Lab. And then I think this bottom with David Sachs, in the age of cybercrime, best insurance may be analog, right? So that's kind of going back to that idea of if you don't need all of that information, there's some ways that, we have a situation right now on one of our stations. It's a booster pump station. We have a different division that actually handles our internal combustion engines, but they need to be able to Ethernet, right, to their equipment. And they have contractors that come in and work on this equipment that want Ethernet connectivity. But we don't need that vulnerability on our network. So we actually have a 485 connection to their information, to our PLC, that's actually riding on our network, because that's adequate, right? The information that we're getting from that controller. And so much of the time, in my background with maintenance, is like, you want to have somebody go out there, look, listen, smell, hear what's going on. I don't want to have where PMs are being done, over the network. It's convenient sometimes to do some firmware updates. We do patches and things like that. But where is appropriate for your system to draw that line? And just think about those type of things. Have those conversations with your other divisions to where people are, they see the big picture of what you're trying to accomplish. And that's really the best thing that I can, say is the communication that you have, with the resources that are available to you, with your other staff that's on your team, that people are informed of what you're trying to accomplish. So any questions? Yes?
How would you take the baseline, an enterprise, about the city of Sacramento, baseline, protocols that need to be talking, systems that need to be talking, and all that? How long?
Well, we're looking at 6 years for this upgrade, right? But we already have a decent baseline, right? And it's just been through the years as it's evolved, right, as to where we are when we began this process. But yeah, we estimate that it's going to take us probably 6 years to get everything up to date. And then it's going to start all over again, right, because your life cycle, right, so it never ends. Thank you. All right. Thanks for your time.